Ciao, Carlo. Very, very nice to meet you. And I would probably do a very, very bad job introducing you. And some of the, well, one of the concepts of this talk is that we really don't need to be self-contained, So the idea is this can be free, and but it would be great if you would just give us a little bit of an outline of what you do and who you are.
Okay, so maybe I'm a strange person because I started as a cardiologist, but first I started to play guitar, classic guitar, for many years, even in the conservatory. Then I went practicing Kung Fu. Actually, I practiced Kung Fu since I was much younger, when I was 7. Now I'm 63. And then I was always curious about try to help people with the disease. This is what I promised to my mother, to help her just in case she eventually all got sick. And then so I went to the School of Medicine, became an MD and then a cardiologist. But then I saw too many people die in the cardiac care unit. So I thought it was better if I will really try to do something to help people. And then I started to do research, which is actually my real commitment. So I became a molecular biologist. Then I went into the trip to think that the heart was like a sort of very intelligent brain, not just a mechanical pump. And at that time, I'm speaking about 1980, 87, 88, that was like kind of an heretic assumption. So I left Italy and I went to the United States. And so I've been for more than 12, 13 years there, not continuously. I've been in Baltimore in a branch of the NIH doing research on this issue. So finally, I provided evidence that the same molecules that we have in the brain that are associated with cognitive efforts or with pain or the antagonizing pain or making calculation and coming out of the calculation and have some more broader perspective of who we are, which are we call endorphins or opioid peptides. They are indeed produced by the heart at a very high level, much higher than in the brain. So actually, I started to realize there was a kind of connection between the ancient Chinese traditional medicine, where the source for the thoughts and thinking is in the heart, it's not in the brain. And so we started to think about a sort of heart-brain axis instead of brain to heart axis that was conceived initially. And but at the same time, we found some intriguing stuff, that the same molecules that were present in the brain and the heart, they were inducing the process of cardiogenesis, which is the start of the heart at the embryonic level. So the heart is the first morphogenetic events, not only in humans, but even in rodents, in insects. It starts from the heart, then the nervous system develops, and these systems are somehow entangled throughout the entire life. And what fascinated me was that we were able to transform even cancer cells, cancer embryonic stem cells, which we call embryonal carcinoma, into spontaneously beating myocardial cells. So from the most powerful tumor in rodents, we could come up with the most differentiated cells. So I started to think about the meaning of shapes, even in a metaphoric way, not just the shapes, the anatomy, but something that entails information, entails a sort of design. And so I came up with the issue that basically what we were focusing on, like the chemistry, the genome, the proteome, all this stuff, is a sort of hardware, but the software is somewhere else. The software is a physical design that it's made by vibrations, by magnetic fields, by light, which is a form of electromagnetic radiation, by sound. And so by providing the first evidence that we could actually do much better with a magnetic field or with the sound vibrations compared with chemistry in order to orchestrate the fate of stem cells. I recognited all this with the, let's say, the vibrational nature of universe. We are embedded in this. We're part of it. So if we think about ourselves like sort of an antenna, then we have basically no limit. But I say this in a very humble way. If we think that everything is human-centered, then we destroy our unlimited nature. And so at the same time, I realized that the sound, the colors, let's say you are in front of a painting, you are exposing yourself to a photobiomodulation. So the colors, they're acting on you. But now we know that we have not only photoreceptors, so receptors sensitive to light, which is an electromagnetic radiation. We don't have this only in our eyes. We have in the veins, we have in other parts of the brain, we have inside, in any organ, we have what we call the chromophores. So these are molecules that emit photons. And by doing that, they start vibrating mechanically. Or if you send a mechanical vibration, then they will start emitting photons. Or if you expose these molecules to an electromagnetic field, they will vibrate and emit light at the same time. But if you think about sound, vibration, emotions, and colors, and these are since ever the expressive instruments for art. So that's the way we started with. About 11 years ago with vid, art science. Vid is coming from it's a sort of, it's a mixed Latin imperative vide, try to see things with different eyes. So then we started with journey with many artists, but not just saying, okay, you see this cell, it's beautiful, so maybe just a piece of art. No, just designing the experiment and trying to make science sort of beautiful dame that is accompanying everybody up to the verge of a saddle line where the power, the exaggerated power of science will die and leave and seize the step to other way of exploring what we are. And then so in this way, basically, artists and science they share the same common pathways, you know. And so then I met with Milford many years ago, and it was really great. Sadly, he passed away just very recently. But
yes, I heard. Yeah. It's interesting. Like it was maybe 8 minutes that you talked, and it seems like you summarized all your life. but I want to dig deeper in certain points in this story. So first of all, maybe let's start with maybe one of the kind of like most obvious, like how much skepticism did you have to fight in your life?
A lot, because of course, saying these things, you immediately go out of the mainstream. So, but I didn't want to publish these studies in alternative journals. I do prefer to send them in very strong, high impact journal, just because we have a moral obligation to change things, so to force. Even the so-called establishment in thinking in a different way, because I think it's an error to keep new ideas, new seminal discoveries in a restricted field. They have to spread, and I have to say that if I have to think now what we're publishing even in Nature about this stuff, that would have been impossible even maybe 10 years ago. It would be crazy. And so things are really changing, and we have to take this opportunity to make people aware, and also the scientific establishment, that what is consolidated science up to now, up to the point that it becomes a sort of obsolete mainstream, was indeed revolutionary many years ago. And so this is we have to avoid this sort of freezing our consciousness, freezing our mind. And so it's important, of course, to have journals in alternative medicine, because they provide a sort of harbor place for people thinking in a different way and providing evidence for such a different way of thinking. But at the same time, it's also important to try to change the actual course. I think this is a moral obligation.
Yes, I agree. And when I said the words skepticism, it felt a little bit awkward to me, because in a way what you're saying is very obvious, right?
Yeah.
Like maybe to even like the not very well educated person, if you explain that every part of us is sort of like a being in itself, and sort of kind of like also communicates in some sort of way with the outside, whatever the outside is, right?
Yeah.
It seems obvious, but like when you kind of like mention it in more of traditional scientific terms, and like you said, like you started like in the mid 80s, and like things were very different then. But I'm very happy to hear that things are changing in the last 10 years,
Yeah.
as you were saying. And so let me find out. So when you started your research, like the first kind of like ideas and hypotheses you had, did they just come from your imagination, or was it something that you were interested in exploring, or was there any particular literature or experience in your life that made you go down that path?
No, it really started from imagination, up to the point that in writing scientific papers, the most difficult part for many years was just writing the introduction, where you have to say why are you starting that paper, that research, and that you cannot say that you just had a dream, or you're playing music and then some inspiration came to you that from the symphony or the music notes, then you go somewhere else and then you see things. So maybe many years ago it was that way. So again, it's a sort of paradox that the same culture that created the scientific reductionism, at their own times, many years ago, they were doing research in a very sympathetic way. Now, even younger investigators, they need let's say a robust foundation, which means that the main risk for this is my former chief in the United States, is like a brother for me, said the most important thing is that you go from 0 to 1, not from 1 to n. And so that one is opening a new landscape. Going from 1 to n is a confirmation of the same stuff, and then this is a route for having obsolete things and obvious things coming on the scene every day. That's a risk.
So you said that you were as a guitarist, you even went to conservatory for a while. And
I had some auditions because I was self-teaching myself. Then I went to the conservatory to see what I was doing, and I went up to the 6th year. But then the rules were changing. There were 7 years, and then they had 3 more years, so I didn't finish. My favorite composers were Villalobos, Oscar Brauer, or Agustin Barrios, so Paul Mongore, Luis de Narvaez, Vihuela, or this even the sound of Vihuela and Butte is very touching.
Yeah. I started playing classical guitar when I was 15. And it had a big impact on my life. I mean, without having had that teacher and that experience with the acoustic instrument, I wouldn't be where I am now. So with you said that your mother has this important role in your life, that she inspired you to become a doctor. Yeah. Can you sort of like recall the origin of that calling?
Yeah, the calling. So my mother is actually she's here in another dimension. She passed away in 2009, and she was very sensitive, but in the real sense that she was able to predict the future, to see things that other people were not able to see, and somehow she passed me this. So when I saw her having some cardiac problems, and I was quite young. I remember I was less than 10 for sure. I decided whatever I'm going to do in the future, I have to save my mother. And so that was the point. I started to think I'm going to be a doctor. Yeah.
Yeah, it's interesting. Like, I think in my family, what I only learned much later was that I have been kind of like gifted with some healing powers, which probably via the music, that's what I was thinking. But then as I was growing older, I started to realize that my father, although being kind of like, let's say, quite simple as a person, maybe, he's always had this self-healing power, like on his own body, which is incredible, like really incredible stories in his life. And he kind of like found this way of healing. But I have to say that like this idea to become a doctor is sort of something that was always a little bit of a, you know, I worked as a nurse in a hospital in the urology department for almost 2 years when I was doing my civil service. And being in the clinical field, let's say, and seeing what doctors were doing and what they were dealing with, I really had no inclination whatsoever to go into that field. And so for you as a cardiologist, how was that first part of your life as a doctor? Was that kind of like very, would you say that it was really like the traditional way of being a doctor, or have you always, even from the very beginning, had your own views and also your own methods?
Well, of course, I had to learn, let's say, usual things. I mean, the standard way of being a cardiologist, but then I tried to merge this with other efforts, like when I finished my specialization, and I was working in coronary care unit. So it was a tough department. And sometimes it happened that you really saved somebody when she or he was on the verge of passing away, and then you realize that there is a magic moment when this chance to survive doesn't come from you, but you have to feel yourself that you really did all the things that you could do, and the only way to do this is just feeling the patients and perceiving the fact that anyways they're happy, whatever happens, they're happy that you're working together in this. And so some of these patients, they called me as a doctor to visit them at home. And then I was teaching them how to breathe, how to do Qigong, how to use breathing and in order to calm the arrhythmias. And the results were great. So this also brought, and you know, when I went to the United States, I still remained in contact with many of them. And even with some of them right now, even if I don't see them personally, but we call each other, they're still alive, and they were supposed to be at very high risk for dying. And then they say, you know, I'm still practicing. Then I didn't tell you that I quit taking some pills because then the pressure went too low, and it was not supposed to go that way. So by practicing Qigong, by integrating the let's say conventional medicine with the other stuff, which I call medicine anyway because it works. Now they feel much better, and they much more balanced way of living. So that was a sort of starting point that that brought me to ultimately just only doing research. Now I'm not practicing.
Yeah.
I'm not in the clinical practice anymore.
So at the beginning of your path, working with these new but old and kind of obvious insights, did you feel alone, or did you find friends pretty soon? People who were thinking alike?
I found lots of friends and doctors. So I realized that there is a large community of people who are very committed, very dedicated to their patients, and they're very serious. They practice this in a very coherent way. And so we joined because it's important to have a sort of critical mass in order to keep these things going. So, of course, some personal growth is something that you have to achieve by yourself, but you have to stay with other people, to confront with other people, to work together in order to achieve the best that you can.
For sure. And so maybe I'm jumping here a little bit, but I'm interested in in your actual research, and with the methods that you're using that I would also like to learn more about. What was sort of like the breakthrough moment for you where you realized that your ideas, let's say, had some truth and also representation in reality? When did that happen, and what was that?
It was around 1995 when I started to use magnetic fields on stem cells in culture, and I saw that I could orchestrate the same things even much better than using chemistry. So the main issue, these cells were sensing part of the vibrational nature of the universe. They were sensing magnetic field. Then I went through very old papers because I was fascinated by the idea. I'm not from Bologna. I'm not born in Bologna. I was born in the south of Italy, in Puglia, in Trani. So I moved to Bologna to study medicine, and so this is the city where Luigi Galvani, in the early 1800s, he started with the frog, with the muscle stimulation with electricity. So, but despite all the fighting that he had with Alessandro Volta, and Alessandro Volta was right in many things, but nevertheless, Luigi Galvani ultimately discovered the bioelectricity, and the fact that we are permeated by electric flashes, by electric currents, and that these may keep us alive. And this, I was aware, of course, by the history of medicine of this pattern, but then it merged. It came to me again. I'm thinking about my mother. This image came to me, and so while I was seeing that magnetic fields were even changing the structure of non-differentiated cells into the most differentiated entity, which is a cardiac cell, and the working cardiac cell that was beating, was competent cardiac cell. Then I went through the literature and I found this name, Harold Saxton Barr, B-U-R-R. He was a professor of anatomy in Yale University in 1920 up to 1950, 58. And he was a pioneer in bioelectricity, and he was studying bioelectricity from in the trees, in plants, in seeds, as well as in animals and in human beings. And he discovered that he provided a strict way to measure the electric field, up to the point that he came up with the clear-cut demonstration that there is a field of life, which is made by physical forces, it's made by electricity. And he conceived that besides having a frequency and amplitude and intensity, this bioelectricity also must have a sort of 4D dimension, three-dimensional shapes over time, and that you have many different times in the same time and space, which is the can I say, the way you look at the given cell, at the given tissue. You're creating the time and the space of observation, but that space entails many different times and space all working together. So it's a multidimensional field. And he was able not only to detect the field with some voltmeters that he invented, and he discovered that, for instance, people with cancer, they had different biofields, bioelectric fields, but he was also able to interfere with the field and provide some rescue and cure. And the fascinating story, if you listen to what I'm saying, then you will say, okay, this guy must have been, surrounded by skepticism, or he never published this stuff. If you go to PubMed, then you will find that he published at least 20 or 30 papers in Nature, in Science, in Development, in Proceedings of the National Academy of Sciences, USA, all journals that provide the Nobel Prize for many people. So that this is even more, it is beautiful from one side, because this means that despite the fact that it was not alternative, more than alternative, was a total revolution, he somehow found within the establishment somebody who believed in this new course, up to the point that some of the skeptics became his disciples and continues his work. But at the same time, it's also very sad, because I'm asking to myself, how is it possible that after having put such a huge foundation forward, there was no subsequent course? And everything went through drugs, molecules, which are important, but not up to the point to control a major issue, which is how do we go from a molecular shape, or from a vibration, from energy, or from the collapse of the wave function of energy that becomes solid matter. How do you go from this that you can find in a crystal, in a stone, and you can find in a molecule, in a cell? How do you go from this to the hierarchical assembly of nanoarchitectonics in supramolecular interaction? And how do you proceed from this up to the cell? And then how do you go from this to a tissue, an organ, or to entire individual? So if you, let me make this example. Let's say you enter in a room, right? I'm fully improvising, and then you want to hack somebody, but you're a molecule, and the other guy is a molecule as well. So the current view is that you have a lock and a key interaction, and upon this kind of an interaction, magically will come up some information. This is what we were learning at university, chemistry, high school, university, and what we were also teaching as a professor. Now, this may be true, if you put some water in the glass and you shake it, you have to shake it, then the molecule, they can freely diffuse and they can do this stuff. Now, let's say that you are in a water, in an environment, and you want to hug somebody to see, oh, beautiful, or I will never hug this guy again because that doesn't provide me the right feeling, okay? And you can swim. It's a little more difficult, but you can do it. Now, let's go inside the cell, and let's just make this comparison. If the gel is, of course, everybody says it's water. 77% in terms of weight, 99% in terms of number of molecules is water. But if you think about it's a gel. Why is it a gel? Because the cell, through its own metabolism, produces glycosaminoglycans like hyaluronic acid and many others. So, and they have different stiffness, different viscosity. So you get stuck into this gel. let's say you're very small, you are inside the cell and somebody is shooting with a gun, and then the bullet goes through the plasma membrane. If your hand is touching the plasma membrane, then this will hurt your hand. If you move, then the bullet will slow down and down, and it will become like a caress. So you cannot swim there. Plus, you're not alone. You have millions of molecules. Just imagine that you are inside this water gel and inside a very crowded street in Tokyo. And you want to go somewhere, and all the other millions of people are coming the other way against you. You will never swim in that situation, and you will never find your partner. So, nevertheless, if you still assume that molecules will create information by free diffusion, which is impossible inside the cell, only in a glass of water can happen this, then how is it possible that even an entire individual is feeling emotions in few microseconds, and in front of any kind of deep conditions or evidence, your blood pressure is changing, your vessel, they change everything, your neurotransmitters are released in a few seconds or milliseconds. This is impossible. So we have to think in a different way. And the way is that inside the cells, what we call the cytoskeleton, the microtubuli, for instance, or the filaments, they continuously vibrate, and they grow at one hand, they're demolished at the other hand. So it's like having the stuff that grows at one end, it's demolished at the other. So it moves and it dances. So it's a mechanical wave. But at the same time, it's highly polarized, electrically polarized. So by moving and by dancing, it creates an electromagnetic field. Plus, some of these molecules, they can absorb light, which is they can absorb the photon that move inside the cell. Even if you don't shed light on the cell produces light in the form of electromagnetic radiation. So you have elastic waves, and then you have elastic patterning of currents spreading at many different frequencies, and you have light, and you have electromagnetic fields. So whatever starts as a local phenomenon becomes non-local by definition. So it transcends the boundaries of the cells where everything may start, and everything starts to vibrate according to resonance mode, into synchronization modes. And so let's say, for instance, that you have your molecules, and they have to meet without touching themselves. How is this possible? Now, think about, I would say all the molecules, they share a common structures. If you think out of chemistry, you see it's a protein, it's a peptide, it's a signaling molecule, or it is even DNA. They have this alpha helix, like a spring, a turn, a loop, and another alpha helix, and so on and so forth. So the alpha helices are springs, so they become like oscillators. And the loops between one oscillator and the other, we're talking about stuff of a few angstroms in diameter. The loops in between these two springs are connectors in between oscillators. Now, it may be mechanical oscillator, but let's think about a few amino acids, lysine and arginine. They have a net positive electric charge on the amino group. Aspartate and glutamate, they have a negative electric charge on the oxygen of the carboxy group. So they are mechanoelectric oscillators, and they create a field. Plus, they can absorb and emit photons. Now, think about music for 1 second. What happens if you place a row of different metronomes who are not synchronized, and you place them on a very rigid surface? They will stay non-synchronous for, let's say, forever. If you place this on elastic strings, then the elasticity of the string will vary and will create more harmonics in the metronomes. And these oscillators will see a sort of dramatic enhancement in their repertoire. of vibration. So they will become synchronous in a few minutes. So just think about molecules like electromechanical actuators that are placed on this circuits of viscoelastic microtubuli and filaments. So this circuit is dissipating differences in vibration in between several clusters. In other clusters, there are other possibility to become synchronous, but the synchronization will be in a rhythm which is different from the other clusters. So you have clusters of molecules that without touching, they start to dance in phase on this circuit. And these are like the actuator of the bioelectronic circuit that is made by mechanic switches or electricity or electromagnetic waves and light. So this is tremendously fast. Just to make this comparison with the chorus, let's say that you need a given number of voices to come up over a certain threshold with a message which comes from the synchronization of different individual voices. And then you have another cluster in another place and another cluster, and they come all together. But in another room, you have other people who are just trying to tune themselves. And so you have a synchronized clusters of voices in the chorus in one room. So now they start to swarm. They start to migrate in the other room, and the other people will listen, and they will start synchronizing in other melodies, and altogether they will come up with another symphony again, or with another canon. And this is what happens in the cell. We have direct proof of evidence in very good journal that all this stuff, they synchronize and they swarm. And from one cell to another, we have this, we call now tunneling nanotubes. So some of the stuff that I was using were carbon nanotubes. We will talk about this later if you want. But these nanostructures, they connect the cells. And the cells, they create further structures and filament by secreting their matrix. So the cells are not separated. They are like the chords of guitar and harp. They are all connected. They are nodes. And what comes to my mind is that human beings, they started with textile art. Very early beginning of our history, we started with that. Then we used chords that vibrate in order to produce sound. Then we came up with electric wires, and then with electronics, and then with sophisticated AI, computational science. So we're just extruding what we have inside, and we created these technologies. But I would do like to talk about technology as in the ancient Greek techne, the creative art of doing, not the way technology is nowadays. It's something that is not meant as something that can really help human beings. It's something that is becoming outside us.
Yeah. You know, there's so many things I want to ask you more about. So maybe like if we just come back to the idea of synchronization, and you say it happens within the cell. So let me just ask you really, like, is there, like, I would, at least from my perspective, I would say, like, because your metronome example, it's natural that synchronization happens if you have separate elements and they share a space. So it's unavoidable, right? It's unavoidable that synchronization happens. That's what I would say. Would you say, what, from your perspective or what you've learned, is there a purpose? You know, what purpose does the synchronization serve for the cell?
It creates information. So information is not something that is a sort of a priori, but is something which is dynamically created over time. But the astonishing thing is that it doesn't go into chaos, but it creates coherence. It creates harmony. And again, this the capability of human beings to create harmony with art, with music, with dancing, with the poetry, with everything, probably reflect this inherent tendency to coherence that we have inside even ourselves. And so the issue, then the main issue comes out that we use this, somehow this term, it's random, or it's noise, it's noisy, and the signal is something much more important than the noise. But probably it's the other way around, that within the noise we have so tiny vibrations, and we have this flow of energy, and the collapse of some wave functions, waveforms, creates solid matter, or many of these tiny vibrations that we don't see or that we think are chaos or random, they coalesce, and then they create sparks, and then a spike, and then you see, oh, that's a signal, it's important. But it is important, but the way it arises from the context is also important. So if the context doesn't have a temperature anymore, doesn't have any structure, do we still have the chance for having a shape and an information? Now the answer is yes. So even in the vacuum is full of information, and the matter and the solid matter arises from this. Now the question is, what's the purpose for this information? And it's something that science cannot answer. But again, if science is humble enough to take you to this front line and let you see the landscape, many other cultures and many other efforts that human beings have done throughout the centuries or the millennia, then probably there is a purpose for this. And this is this word that it's love. I mean, it's love. It's pure love, and then that creates the supreme force that creates coherence. And then it's people are often, especially scientists, they're scared about pronouncing this word sometimes because it's something that maybe brings to philosophy, religion, whatever. But and it's not so reductionistic like science uses to be too often. But yeah. So there is this purpose, and then so the information, it's not the electric field, it's not necessarily the magnetic field or light or the vibration per se. These are the carriers of the information. It's like information is something that's is sitting on this automobiles, and then the drives the engine and towards a given direction.
Yeah, so it's the pattern, and it's the flow of one state to another, and like the constant progression of order within what some people may call chaos, but then probably it's just a different order of pattern, or of or different order of order.
Yes. Even the complexity. Sometimes we are scared about the complexity or the chaos or the randomness. But if you think that it's just scale free, it's a sort of unlimited world of opportunities, then it's something beautiful, I think.
Yes.
Even if everything was already known, it would be so boring that
Exactly. Hey, so in 1985, when you had the success of manipulating the stem cells with the electromagnetic field, like what you described were like the positive outcomes. You were able to transform the purpose of a cell, right, even into something very specialized.
Yeah.
And so, but within your experiments, did you also, I have to ask this question, I don't really want to, but did you also find that there was a way that you could be used in a destructive way, the electromagnetic field?
Yeah, absolutely. So let's go with some order. So the first experiment were just done with a field that I didn't know how and what to start with. So I started with a field of 50 hertz and 0.8 millitesla, which is basically the electromagnetic field which is generated by the domestic power line.
Mhm.
So in that way, we were only able to afford cardiogenesis, so cardiac differentiation. Then we moved to another stuff, and a technology which was not mine. I didn't invent it. It was named radioelectric asymmetric conveyor. And this technology was invented by a friend of mine, Salvatore Rinaldi, who lives in Florence. And then they wanted to understand how it was so powerful. And so it was a generator of magnetic fields at 2.4 gigahertz. Now I'm trying to answer your question. 2.4 gigahertz is Wi-Fi energy.
Mhm.
It's the same energy that is still used worldwide to connect via internet.
Mhm.
And it's called Wi-Fi, wireless fidelity. And but the Wi-Fi card in a computer, the same we're using now, it's emitting irradiated power about 12 to 14 milliwatts. And our cells, as far as we are alive, as human bodies, we do emit around 60 milliwatts. Now, this device was emitting at 2 milliwatts, so the field was extremely weak. But there was a cable with a probe that was intended to deliver and to concentrate the field in a specific tissue that the inventors wanted to heal or to improve. Then they found that some of the instruments were much more effective, and we found out together that the cable was not connected, was disconnected. So we started to think, how is this possible?
Mhm.
That the most effective results were afforded by an equipment where the cable that was supposed to focus, to concentrate the field in the tissue that you wanted to heal was more effective than the good equipment. So we made a replica of this working on the stem cells. And indeed, without the cable, the effect was very weak and not always reproducible. With the cable going inside the culture medium where the cells were growing, the effect was astonishing. We could drive many different commitments and differentiations, not only cardiac, but even neural, skeletal muscle, bone, cartilage. And then we started to figure out why, which is what we published in Nature Scientific Reports and many other important journals. So wherever you are exposed to a magnetic field, the living tissues, the living cells inside the tissue are creating an endogenous electric microcurrent. This is known since forever, that when you apply a magnetic field, then the cells are creating a microcurrent in response to the field. Now, imagine that this microcurrent are like dispersed into the environment. It's like saying that the cells, they don't know that they are creating this response. So the probe, the cable, was attracting this microcurrent and sending them back to the cells, just creating a loop of microcurrents without depth limits, up to the point that the cells were creating a sort of resultant microcurrent, again attracted and sent back by this probe to the cells. So the cell became somehow conscious, aware of a sort of an endogenous electric signal that they were generating in response to a very weak incoming magnetic field. So that's saying that the cells were somehow constructing their own signals, the signals that they were using in order to afford a major outcome, which is creating and optimizing their electric polarity. So once the cell, the stem cell, they go through a decision, they have to optimize their electric polarity, which in turn becomes structural polarity, structural vibration, polarization of vibration, different elements. And so they become more and more capable of doing what they are designed for. So if it is a stem cell and it is an adult stem cell that is not so powerful like an embryonic stem cell, the same adult stem cell will be reprogramming herself backward in time, like it was an embryonic stem cell, but it is an adult one. And so this is how we discovered stem cell reprogramming without using viral vectors or the other molecular engineering, like Shinya Yamanaka, for instance. He got the Nobel Prize in 2012 for reprogramming adult stem cells or even cells from the skin into embryonic-like stem cells. So we succeeded in doing the same thing without viral vectors, without, let's say, cumbersome chemistry, but just with a field. Now, it happened that once we sent one of these machines back for tuning, for revision, and we received it back, we were not able to, we were only killing the cells. So I said, oh my God, what's going on? Then we found out that the way the system was tuning, because after learning the story that the cell was sending back its own microcurrent, that the probe was attracting and sending back the currents, we started to create a program to optimize this back and forth messages from the probe to the cell. So by chance, what we thought was the optimal timing was very close to a sort of an error. So just moving the interval in between one pulse and another for sending back this endogenous current back to the cells, by moving the pulse in terms of intervals a little bit more, we went into a context that was really harmful for the cells. So we moved a little bit backwards. We prolonged the pulse intervals within the same stimulus and another, and everything came back to normal. So we were again able to optimize the stem cell differentiation, the capability to rescue damaged tissue. Just to say, to answer your question, it's really possible that a very positive message can be turning into a very harmful one, and a very dangerous one, just not by changing the structure of the stimulus, but just changing the absence of the stimulus, which is the pulse interval, which is a lot of things to do with music. The pulse is so powerful. The absence of sound after a given melody is so powerful in creating emotions and expectations. And again, our cells, they behave the same as we do.
Yeah, you know, I have to think about resonance frequencies and like feedback loops all the time as you're explaining this, which I have like a lot of practical information with or experience with, you know, in my work. But I'm also starting to think, because I'm not obviously not a specialist, but you can maybe explain that. But the way that the DNA, the code, kind of like creates both the plan and the materials coming from, I don't know, I'm just saying this because I'm assuming it, that it's also some sort of like feedback, like a biochemical feedback system that then starts creating the cells, right? Is that correct? Would you say that? Because then it wouldn't, you know, then it wouldn't surprise me also that the same principle kind of like it is intact when there is a grown-up cell, right?
Yeah, let's say this DNA. It's a very long molecule. It's more than 2 meters long, and it's packaged inside a very tiny nucleus. If you just try to draw a diameter, the nucleus may be 20 microns, something like that. So just imagine this long molecule that's packaged. The molecule has to twist many times, okay? Million and million of times. Now, the way it does this, again, it's like helix, turn helix repeated many times. And so then you have packaging into the chromosomes, and so you have chromatin. But if you think about the part of the DNA which is used to in the transcription that becomes a primary transcript, and let's say messenger RNA, it's less than 1% of these 2 meters, and such a 1% is spread along these 2 meters. And so you have many different contexts. So the vast majority of the DNA was deemed as junk DNA or garbage DNA, because it was not supposed to do anything useful for the cell and for biology. Now we know that this part, the garbage DNA, is probably the most important, because it has a structure. All this bending, these loops, they continuously vibrate. Vibration is again mechanical, electric, and can come into resonance modes. Let's say, for instance, that can you see this? This is DNA, and this is a starting point for transcription, where you can place whatever you want. It's just a transcription machinery. So the transcription factor, there are these guys that tell this part of the DNA. Now you start making messenger RNA. They were supposed to go here. And this is the noble part of the DNA. This is part of the 1% that I was talking before. Now, let's say that the transcription factors and all the things that regulates the transcription doesn't bind here, but here, far away. And all this part is garbage. Now, by the way they bind, they make a loop like this. Mm-hmm. And this loop has inherent forces. So elastically tends to open, but this actuator keeps the loop. So there is going to be vectors pointing outwards that tends to follow the elastic structure of the DNA, which will tend to reopen. But these transcription factors will bend the DNA. So this loop will have vectors going outwards, elastic forces of the DNA that will tend to reopen, and vectors, tiny vectors going down, which are created by the transcription factor, by this guy that doesn't bind here and bind far away, so it bends. Now you're going to have a resultant vector, and it's like a pushing hand that will push the transcription machinery forward, enhancing the velocity of transcription. Then you will say, oh, this is an increase in gene expression. This gene is working much faster, and it will create much more messenger RNA, which means much more proteins, which means much more information. Let's say the loop is going this way, and the vector is just blocking the transcription machinery. Then that gene is inhibited. Now, this loop is vibrating, and it is transmitting its own presence across the other 2 meters. So this system is consciousness, and it is mechanic, electric, and light. So it is an antenna resonating not only inside the cell, but this is why we know that music and art, they can speak to the innermost dynamics of our biology, because they can change the transcription of our genes. And the sound vibration is not only mechanic sound, it's a sound of light, it's a sound of colors, it's a sound that replaces ourselves in the vibrational context of the universe. So it's musica universalis, in this sense. And so it is much more than a genetic code. This is why screening the sequence of DNA, it's only a tiny part. It pertains to 1%, exactly like thinking about the universe in terms of solid mass. That means less than 5%. 95% is dark matter and the dark energy. Dark because you don't see it, but you see the effects. And these effects are moving the galaxia, they're moving the universe. They are rotating, they're spinning. So all the same stuff is going on in our cells.
So let me ask this question: like in current technology for genetic engineering, right? Do they take into account any of this findings, or do they? No.
No, but again, things are changing, and so people start to go back to these ancient findings, like the ones that Harold Saxton-Barr provided many years ago. And there is a large growing community of scientists worldwide that start thinking in a different way and producing compelling evidence, and which is even more important, real chance for cure, for tissue regeneration. Mm-hmm. For instance, one of these investigators, Michael Levin, who works in the Tufts University near Somerville, near Boston, he has done wonderful work in bioelectricity and somehow continued the seminal discovery of Saxton-Barr, and then he came up with very fundamental issues. Let's talk about the future in medicine, which is regenerative medicine. For instance, he provided evidence that there are these creatures like the Mexican axolotl, it's Lacusta salamander, or the triton, the zebrafish, and they regenerate astonishingly part of their body. They say the Mexican axolotl, you can put them inside the labyrinth underwater, and they will create extra copies of their own brain in a few hours, like a tumor. And they will start, thinking in much more complex and faster way. So they escape the labyrinth. When they are outside the labyrinth, they destroy this extra brain by apoptosis. Now, can you imagine if we can do the same thing? Problems like Alzheimer's disease, Parkinson, stroke will be vanishing in a moment. Now you will say, these creatures, they must have a different DNA. No, they're almost the same as ours. The same animal, you make a lesion in the heart, just you cut the apex, which is terrible. They make a blood clot, and then 3-4 weeks, the heart is perfectly back. What if you block bioelectricity by blocking the flow of currents inside the channels, or you shield these animals from the way they resonate with the geomagnetic field, the magnetic field of the Earth? They behave like us. They're not able anymore to regenerate themselves. So again, the genome, the proteome, all the chemistry. I'm not saying it's meaningless. It's very important that this is the hardware. The software is somewhere else. So, and we have to retrieve our own ability to resonate with the universe. Music and arts are one of the most important pathways to me. Of course, we can create devices, actuators, wearables, whatever. In my crazy mind, these are just facilitators of what is expecting us in the next jump in evolution. So, is there a morphogenetic code? Yes. Can we try to decipher this code to understand how it works? The answer is yes. For instance, what in the turning point for me was many years ago, was around 2002 and 2004, where when I met this fantastic physicist is working in University of California, Los Angeles. His name is Jim Tseski. And his companion, Victoria Vesna, she created the Arts and Science Lab in UCLA. And they're doing wonderful work. And then, so together with Jim Tseski, we started to work with his microscope, the atomic force microscope. And just imagine a finger of a blind man, just a few microns. And then here's a probe. It's a carbon nanotube that is only 5 nanometers in the diameter. So it ends up with a single atom. That means that your finger can touch a single atom on any given surface, including a cell or part of the cell. So in this way, if you move and you touch the surface, even a single molecule will appear in this tiny scale like a huge mountain. So your finger will do like this while it's sensing the environment, the nanotopography. If on these fingers you project a laser beam, during this movement, the laser beam will change its own reflection angle. So you can sample this light, and by the light you will create a multidimensional map of what it's not seen. It's perceived, because a conventional microscope with its own lenses is a projection of human eyes. This one is like the finger of a blind person. And so then you come up with a fantastic discovery that shapes are created, generated, and unfolded by the vibrational dynamics of forces that concur to the generation of the shape. But the shape per se, it's not stable. It is a continuously vibrating entity, adjusting itself to the environment, and creating, contributing to the same forces of the environment. So let's say that you are in a mechanical environment, but you are also electrically charged. Then you will contribute mechanics, electromagnetic, and light, and you will resonate by these forces. So this is going to bring us to a sort of theory of unified field, where you cannot separate these forces. Let's say that you touch the strings on your guitar, and then that's a mechanical vibration, but you're touching your fingers. There is electricity on your fingers. And this, there is humidity in the air, and there is light going on, and you cannot separate this anymore. So the question is, it's vibration. It's not just to use a vague term, but it's just to have a broad term, broad enough that can embrace all these different, these multifaceted entities. And now the question is there code in these cells? So do I need to figure out a frequency, magic frequency? And we came up with the conclusion that there is no magic frequency, but there is a symphony, there is a melody in these cells. So what we found is that it happened by serendipity that we wanted to tune the system. And so in order to tune a system, you need to be sure that you're not dealing with artifacts. So we placed this atomic force microscope in this probe on very simple cells, like yeast cells. They're very simple, but they have a very, complex metabolic activity. So if you change the substrate, you change the food in the system, they will start recruiting genes that will encode for the enzymes that will use that particular food. If you change the substrate, another set of genes will be recruited. And if you change the temperature, the genes will work at different speeds, different velocities. So we found that there was a vibration, only few nanometers, only few carbon atoms stuck onto each other, and there were musicians in this lab. So they basically rose the pitch of the vibration, and we found that whenever you were changing the substrate or you were changing the temperature, there was like a symphony, not just a frequency. And then the same thing happened when I met Milford Grace. He was a fantastic drummer, fantastic percussionist, and he was also a fantastic scientist of the sound per se. He knew most of everything about the sound, much better than a physicist. And so he was thinking that the way the percussions were born was it was an ancestral time where people were feeling their own heart rate variability. So the variability within one beat and the other. So this interval is surprisingly variable in the most healthy people. So if you plot this variability over time, you may come up with the sinusoidal curve, and then you say it's a coherent heart rate variability, or it may be completely deranged if you have heart disease, for instance. And what's important, if you try to cure a cardiopathic patient, then the heart rate variability will turn from a non-coherent to a coherent fascia. So in the mind of Milford, the heart was the baby field. He was aware that it was the first morphogenetic event, and also the way the tribal rhythms were fashioned was to avoid adaptation, because adaptation is a sort of death for biology. If it becomes the same monochord rhythm, cell will die. And you can see this very, very easily in culture. So if you try synchronizing cells on what you think should be important, they will die. They need to come up with their own variability, with their own polyrhythms. And so he started to record the sound of the heart with an electronic stethoscope. But instead of doing what a scientist would have done, which is just analyzing the sound, he went back not to the sounds you can hear, something that you can hear, but to vibrations. And he found just a part of the heart cycle in the beat, in the heartbeat, that was coherent, which means that by plotting the logarithm of the frequency versus the logarithm of the power of the sound, he found some frequencies that were on a straight line, which means that if some other matter was present around this spot of vibrations, then matter would have been arranging itself with a given geometry, something that Chandley, for instance, has done in the history of music. No? So in this way, the frequencies were around 5 hertz, so you cannot actually hear any sound. So he rose the pitch, and if you were just listening at 2/4 heartbeats, it was not like tutun, 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 it was a melody. And by giving the same melody to patients, he was healing their own rhythm, and he was curing himself. He found, unfortunately, he found to have a cardiac amyloidopathy. It's a very severe disease. It's the accumulation of amyloid protein in the heart instead of having it in the brain, like in the Alzheimer's disease. So it was always very brilliant, but it's a genetically encoded disease. He had this in the heart, and he was supposed to live just a few months. He was keeping going and going. And the way he was saying, I became the explorer of humanity of my disease. So it was very profound. And he was saying, even in such a condition, the rhythm are very different, and the way you can talk through this rhythm still makes my heart my true composer and my true conductor. And this is great. And we did that experiment in 2016. I don't know if you know about the cell melodies that we did in Bologna.
I do not know.
That was really touching, because he came to Bologna, and he was not allowed by his producer to give a concert. So it was a scientific experiment. And we were on the stage of this theater, which was arranged in an ancient church in Bologna. And we had a microscope equipped with a hyperspectral imaging camera. So it's a special camera that can follow the vibrations of cells by monitoring the scattering of light. Like instead of using the atomic force microscope that can keep trace of a single cell at a time, then you can look at the entire culture of cells, or even at the entire individual. And then what is beautiful is that we found that while he was performing, cells were passively adapting their own vibration to his own rhythm. But then he was instructed to keep the phrasing a little bit longer instead of changing immediately. And the cells were, for each phrasing, were then developed their own rhythm, and so on and so forth.
Mm-hmm.
So they were feeling this rhythm. And that was a world premiere. Then I had also this actor who was, his name is Alessandro Bergonzoni, was requested to speak with a loud voice some comics, to talk about some comics and make people laughing, and then to talk to the cell in a dramatic improvisation. And so again, he was quite far away from the cells when he was speaking with a loud voice. He was very close to the cell when he was delivering this dramatic speech. And the main context of this improvised speech was, okay guys, your cells and your stem cells were supposed to regenerate ourselves. Can you take us from out of our subhuman conditions? And it ended up like an answer that was like misery. And so we were keeping traces of this different behavior. So the question was, first of all, is there any different behavior? And it turned out that then it was just speaking with a loud voice and delivering a very superficial message. Only the plasma membrane, the surface of the cell, was vibrating. When he was delivering the tough message, improvised one, he was close to the cell. So this allowed us to sample a moment from his own voice with the same sound pressure, in order to make a comparison that was not related to the intensity of the voice, but it was related to the meaning that it was trying to deliver. And in this case, only the nucleus and the DNA were vibrating. So this was published also as well. And from that moment onwards, we continued to work on this. So we've done another some melodies with a dancer. Mick Zeni was the first dancer at the Teatro La Scala, and we recorded its own heart rate variability. It was very, so its physics was very tough. So the rhythm was coherent, the heart rate variability was coherent since the beginning. So we said, is there anything that can create deep emotions and you have to make this rhythm going crazy and maybe super coherent? Then he recalled, he was remembering a piece on the piano, and there was a pianist there. He started to play this piece of music, and so we recorded deep emotion in the heart, and the heart rate variability became super coherent. So we sent these traces from Milan via web to my lab in Bologna, and by mechanical actuator, we delivered the same traces to stem cells. And only the super coherent ones were able to make the cells and to create an increase in proliferation number of cells that were growing in culture, and even optimizing their own metabolic activity. So that means that the emotions that he was feeling was traveling through the body. You can imagine that the sound from the heart can go through the capillary vessels everywhere. So it's this in our mind was just somehow making aware the audience of the feelings that can move an artist, and the audience will become sort of an explorer of these feelings, and vice versa. So we're still perfecting this kind of an experiment.
It's really everything's really obvious that you're saying, right? In a way.
Yeah.
And I find, having worked with music all my life, and having, you use the word love as sort of like to describe maybe the software that runs on the structures, let's say, that are there.
Yeah.
And my love for music has led to this understanding of picking up on these signals, well, let's just say things that are between the lines, right? So the meaning, the kind of like what language really is about, right? Language is, if you take the meaning away, language is just, you could say it's noise, right?
Yeah.
But as we know, there is meaning conveyed with it, and I'm fascinated by the prospect of use, or of what you're saying, that even cells can kind of respond to meaning, which
Yes.
is absolutely fascinating. And can I ask you to maybe something about the practical implications, for example, in cardiology? Because like how, I mean, just this is just really like a technical question, but like how
Yeah.
does one use stem cells to heal a heart?
We don't, we are now deciphering the signatures from the cells and from the tissues. Even in vivo, we can do now. And so there is no magic frequencies, but there is a symphony, okay? It's a melody. So there will be a melody that the cells will express when they're trying to resist a hostile environment like hypoxia or damage, or let's say myocardial infarction or stroke or any other damaging conditions. And at the same time, there's going to be a symphony that the cells do express on many interconnected levels, vibrational, electric, magnetic, when they transform themselves to cardiac cells or neural cells or skeletal muscle cells, or bone cells, whatever. And there must be also a way cells become younger and younger, which means not just some aesthetic medicine, but they recall an ancestral memory, and they merge what was going on at the time of the embryogenesis. Just think a singularity, a single oocyte, that like the Big Bang, it gets fertilized, and this wave becomes an entire individual. And at the same time, why is it possible that during in the embryo, any defect leads to spontaneous abortion, and these totipotent stem cells are not able to rescue an embryo? This is why they're still forming the tissues and the organs. They don't know the story. The story will come later with the adult cells, but the adult cells, you don't need to kill an embryo to have embryonic stem cells. This is another message. You can reprogram your adult cells and even your skin cells. They are not defined. They can go back in space and time. They become embryonic. Plus, there is now this recent discovery that we have this, it's called MUSE, M-U-S-E, MUSE cells, that is multi lineage differentiating stress enduring cells. And these are really embryonic-like stem cells still retained in our tissue. So what we call the adult stem cells are probably the guardians of these cells, and they avoid these cells, they drift, for instance, into cardiac or metastatic cells. So now, just think that sound, light, magnetic field, electric field, by definition, they share diffusive features, so they can pass through your body. Even a sound can be attenuated, but it goes through. And so we're relying upon the diffusive features of the physical energies to target the stem cells where they already are. They're resident in all the tissues of the human body. So we don't need to transplant stem cells anymore, but we can reprogram those cells in place and where they already are. And just it's a way of boosting our inherent ability for self-healing. You were talking about your father and his ability for self-healing. So just imagine that some of his knowledge can be passed to the others. And it's like the information is in his cells, may spread and teach other cells how to do the good job. And so all the devices that we're doing, they're created in a form of wearable, something that you can wear, something that some energy, light or mechanical sound that you can deliver in a given tissue. Because the same waveform will sort different effects according to the tissue and the context where you deliver it. But then you don't need to transplant stem cells anymore. And again, this is disruptive because this wave are very cheap. They can be used in everybody, but still they can be tuned in such a way to make, yes, regenerative, but even precision medicine. According to the individual needs, we're still on the trajectory of harvesting those signatures. It's not so easy because then we have to discriminate between noise or better understanding how noise creates the signals, and so the signal must be amplified, but the noise must not be destroyed completely. And so this is somehow tough, but yes, this is our strategy, and there are some promising results, and we hope that in a few years we may come up with a number of can I say signatures and devices that we can really help people.
But for now, the arts and the arts in general are probably the safest way to heal yourself. This is
absolutely. Yes. And this is something that everybody should practice. Everybody should understand in which art field she or he is more prone, and practice every day, because it's so important. I mean, it's not just 10 minutes or 1 hour every day. It should be kind of commitment. Yes. Also practicing other disciplines like whatever you think, maybe yoga, maybe Tai Chi, maybe Qigong, maybe painting, is something that really is feeding your consciousness, because of course, the information of consciousness is something really fantastic. It's this wave of love, but it may speak through photons. It may speak through a dance of physical energies. So that's again, doing this together, convincing people of the strength of this will also create a different awareness. So I'm confident that our biology will shift to this, will change in the good way. Now we're witnessing a situation where everybody wants to change the biology of human beings for his own purpose, for his own benefit. But I'm sure this won't last. I'm confident that a new course of deeper understanding of each other's, and that the only way we can really evolve is through a jump of consciousness, and just trying to really eliminate duality, eliminate this idea that where is light must be necessarily also the dark. Well, it's always been that way, that people have been suffering, and people have been doing the worst things to other people. Like at the same time, people are doing wonderful things. We have to come up with a deep choice that is abandoning this continuous alternating stories. And
I'm very optimistic as well, and I believe though that this jump in consciousness, or like the level of consciousness, it's something that maybe, well, this is just like how I imagine it, would be something like you go to bed at night and you are a being with only one eye, right? And in the morning you wake up and you have two eyes, but in that moment where you have two eyes, you don't really have access anymore to the person or to the being that had one eye. Yeah. And so that's how I imagine like these jumps in our evolution. And,
beautiful.
So we may not even realize that we have jumped, you know.
Yeah. Yeah.
You know,
Yeah.
there's one thing in my art that I'm sort of like a little bit obsessed about. I have been for a few years, is like to transfer the musical relationships, just say the intervals that I play on my instrument into corresponding movements where there's like a coded system where like a specific movement means a specific pitch. And then there's also, because like with a guitar instrument, you have obviously copies of that string. So you have different scales of vibration in one instrument, which is amazing because it teaches
Yes.
you to scale
Yeah.
intervals to different materials.
Yeah.
And so the system that I'm teaching is where like specific movements along the instrument, along the strings, can corresponds with specific sounds. And then you can switch the whole thing around between the hands. And the fingerings remain the same, but the spatial relationship, which kind of like existed on one string, gets then transported onto two adjacent strings. So that means you're learning the dimensionality of one string, and then crossing over to other strings. You're learning the same relationships, and it's a wonderful thing.
Yeah, beautiful. Beautiful.
Yeah.
It's fantastic. Wow.
Yes. And you know, and speaking about improvisation, it's always such a for me such a almost humbling experience to allow my body to oscillate, right? So it's that it doesn't have to be my brain or my thoughts, you know. It's just my body oscillates, and to just move my body to make the sounds. And it's connected. And this is maybe because I asked about the skepticism first, right? Because I have a lot of skepticism even towards my own art. Like, I know I can do it, and I do it. I just kind of like say fuck you, right, in a way.
Yeah.
I'll do it anyway. I'll
Yes.
just move it.
Absolutely.
And yeah, and
Keep going, my brother.
And then what comes out is kind of like so intense and kind of also wrong in a sense. Like, there's so many things happen that are unplanned, so many things happen that are surprising, and because they're surprising, I find them exciting. But at the same time, I think there's also this part of me that compares what I do to what exists traditionally, let's say, and it's like this constant flow and back and forth between like the conscious and subconscious, and it's this, like you say, it's this dance.
Yes.
Right? And I have to say, I experience that most of the time of my conscious life, you know, this dance. And it's a wonderful thing. And now, having heard your perspective, also explaining the the biological foundations, really. And I mean, like I said, for me, as somebody who doesn't even ask, I don't even ask myself the questions that you ask yourself. To me, I say yes, right? I say yes, Carlo, yes. And I would like you to give us many more papers and publications, you know, as many as possible, so that others can kind of like jump on the train. And I'm curious about how things will go. And the pandemic is sort of like an interesting trigger, I would say, for change. And I have to say that I don't have a clear vision for what's going to come, but I'm certainly curious.
Me too. Yes.
Yeah.
And I have faith. I'm confident that okay, we're seeing many bad things going on, but also we will have many good things, and we may have a choice, and then it's up to us.
Mm-hmm.
So
yes. So do you still play music?
Yes. Yes.
Yeah,
Sometimes, yes. Yeah.
yeah. And do you still play guitar?
Yes, classic guitar. I don't have much time to, can I say, to improvise or to refine, but I feel good, and I feel that the way you touch the guitar is creating completely different feelings. So the polyphonic structure of the guitar, even if it's a very simple classic guitar, but I've been somehow lucky because I started with many master classes with Alirio Diaz when he was in Italy. So he was a direct disciple of Andres Segovia. And again, Segovia was self-teaching. He was teaching himself. He didn't go to a real school of guitar. And then he came up with this wonderful touch that he has. The way he was keeping the right hand was very peculiar. Then many others they said it was wrong, but to me it was the way he was using the fingering was really amazing. That's something that I learned. So it's like a precious gift for me. Whatever I want to listen to.
I believe that people who are using strings to make music, we really have the most direct connection to the experience of vibrations and of the origin or the material or the software, whatever you want to call it. And we experience it directly. We experience it even like without anything. There's no intermediate, no medium in between somehow. And
no, right.
With this instrument that I play, which is just a regular guitar basically, but the way that I play it, where I just use one finger to hit the string, I even remove the need to synchronize the picking and the fret.
Wow.
So it's even more immediate, and it's like it's really like the range of expression is pretty minimal compared to regular guitar. But what happens is that we're in this field, in this smaller field, the resolution explodes. Like any single movement, any single thought, any single emotion I have sort of like immediately kind of interacts with the vibration of the string, and it's this feedback loop, and it's a wonderful thing. And even without if I wasn't making any music for other people, I think I would be touching strings well almost every day.
I understand you. It's so beautiful.
Yeah.
It's so touching. Yes,
it's touching, but like so there's so many people that play keyboard instruments though, and I love the grand piano, the sound of the grand piano, but in terms of having like a direct experience of the vibration, having the keyboard in between the fingers and the string is really removes you very
absolutely
far
absolutely.
from anyway.
even the way you breathe, if a very good classic guitar, the way you breathe it will affect the sound that comes out. So,
yes, yeah. It's a magical world we live in. And what are your future plans?
well, future plans, I would love to complete this journey, this part of the journey in harvesting these melodies, and somehow come up with a repertoire where we can pass all these discoveries to artists and walk together and walk this line and discover new things together with artists and scientists, design experiments together. This is my future, and I'm sure that these two fields will come back together as a unique field, as oneness. They must come together again, because they were not separate in ancient times. I mean, science and arts, they were one unique field, and we cannot explore most importantly, we cannot co-create reality if we don't come back together again. And then it's just recognizing some brothers that maybe have been working together in other lives, and then so I see you and may ask you, where have you been all this thousands of years, probably? So it's time to work again together. So that the feeling I have, and of course, in the meantime, if I can come up with some device that may act as a wearable, as a facilitator, or just delivering this melodies, I would be more than happy.
That sounds like an amazing aim. It's pretty much very similar to what I think I'm doing, or what I'm probably not always doing, but when I have the freedom to create, that is sort of my objective. Yeah, I still have so many things to say. Like for example, I had one incredible experience with an Italian in '93. I was in Venice, Venezia, and there was a young man who kind of like, that they have this palmistry place where people pick your hand, and so there was this guy who took my hand, left and right, and I can remember, and looked at it and said in English, "This is the oldest hand I've ever seen. Go away." This is like one of my first experiences in Italy.
Wow.
And it's become a sort of like even I had a phase in my career where I had my palm as my logo because of that experience.
Beautiful.
Yes,
Beautiful.
yes, yeah. I mean, let's obviously keep in contact and
Absolutely.
talk again, because I have some ideas I want to share about like the melodies that you're talking about. I believe that there is a principle for construction, even if I may say so, of these melodies. There's a natural principle, even like in the generation of the system for music that we're using with the 12 notes. There is a simple explanation why it exists, I think, and why we have the pentatonic scale and the diatonic scale, and there's simple explanation, and there are principles, and I wouldn't be surprised if these principles could be used to create powerful sounds, let's say powerful melodies, or as you say, symphonies, because I agree. If you overlap many cycles of musical logic, let's say, you create a symphony.
Absolutely.
And that is what happens when an endless number of elements interact in our world. It creates this amazing symphony. And
absolutely,
there must be a way to get somewhat close to it, with I think we can make that kind of sound.
Yeah, let's do it. Let's try.
Let's do it. Let's. Okay, Carlo, it was a real pleasure. I think we've talked almost 2 hours, so that's enough.
The same here.
Yes,
it was so beautiful. Thank you.
It was so wonderful. Like it was amazing. I will listen to this again many times, and I will write down some more questions for next time.
Okay, I'm here.
Yes. Okay.
Whenever you want.
Yes. Okay. Thank you so much.
Thank you. A big hug.
Ciao. Big hug. Yes.